Hello everyone, my name is Tanya and today I'm going to present our work Equi-explanation Maps, Concise and Informative Global Summary Explanations. This work has been done at UMass Amherst in collaboration with Professor Razieh, Rahimi and Professor James Allan. The research problem that we deal with in this paper is relatively new. For example, assume that we have a classifier that helps choose between three treatments A, B, and C to cure heart disease based on a host of patient features. Now, suppose a doctor is trying to verify the sanity of this model before using it to make critical decisions. We claim that existing local and global explanation methods are not suitable to solve this problem. What we need are explanations of varying granularity. For this purpose, we propose Equi-explanation maps. Equi-explanation maps take in a classifier and a granularity coefficient epsilon and return a set of equi-explanation regions or subspaces along with their corresponding attribution vectors. For example, assume that we have a binary classifier with two features, feature 1 and feature 2. Equi-explanation map would divide the region of interest of this binary classifier into three equi-explanation regions, R1, R2, and R3, and provide feature attributions for each of the equi-explanation subspaces. Next, we discuss a method to generate equi-explanation maps. While a host of methods can be used to generate equi-explanation maps, we concentrate on EMAP, which we have proposed to optimize on the problem. EMAP first computes the approximate convex hull of the region of interest and then divides it recursively based on the granularity coefficient epsilon. Once we have received subspaces, once we have received hypercuboids which have explanation standard deviation less than epsilon, we try to merge neighboring hypercuboids together on the epsilon constraint. These merged hypercuboids together form subspaces. And next, we compute aggregated subspace explanations, which are then presented in a tabular representation, which is both informative as well as concise. To verify the effectiveness of equi-explanation maps, we conduct a host of experiments on two datasets. We compare equi-explanation maps with SP-LIME, Guided Line, SHAP, and MUSE, which are all global explanation methods on grounds of interpretability, fidelity, and informativeness. It is important to note that informativeness is a new explanation evaluation metric which we propose and believe is overlooked by other explanation methods. Here are the results of the comparisons between EMAP and the other methods. We observe that EMAP outperforms the other methods on fidelity and informativeness on both the datasets, however, gives subpar performance on grounds of interpretability. We also conduct a user study to compare the feature attribution-based equi-explanation map result, which is here, to mimic model-based cascading if-then rule lists here, since these two cannot be compared quantitatively. Our volunteers report that equi-explanation maps outperform the mimic model-based method on most parameters, especially as the number of features increases. Lastly, we conclude our work. We present Equi-explanation maps, which is a data format, new data format to generate concise summary information explanations. We introduce the metric of informativeness and show gains on grounds of informativeness as well as fidelity. We also list a host of future work. Thank you.